Hello, my name is Zach, and I'm a part of Team 3, along with June, Matthew, Connor, Jared, and Allison. We plan to analyze and redesign the mounted manual pencil sharpener. The function of this device is to sharpen wooden pencils of various sizes. The user turns a crank to rotate helical cutting gears around the end of a pencil to make a sharpened point. The case of the pencil sharpener catches the shavings, protects the user from the sharp helical gears, and reduces the noise of the sharpener. The wheel on the front of the case can be turned to accommodate different diameter pencils. The primary customer group for this product is school administrators and office managers who would want a rugged pencil sharpener that can be permanently installed. The secondary customer group is individual customers who may want it to be more portable. The expected production volume for this product is about 100,000 units annually.
This is the exploded view of the mounted pencil sharpener kit. The pencil sharpener has 3 sub-assemblies, including shaving catcher, sharpener mechanism, and crank sub-assembly. On the right side, you can see the detail of the shaving catcher sub-assembly with size selector. The left side is the crank sub-assembly that takes mechanical energy from the user and transfers it to the sharpener sub-assembly shown on the right side of it. The sharpener mechanism consists of multiple gears that accepts the user input and cuts material from the pencil inserted at the center.
Alright, so here is our fast diagram for the pencil sharpener. Our primary function is sharpen pencil, and that breaks off into our 2 sub-functions, which are cut wood and control movement. We accomplish the cutting of the wood by transmitting mechanical energy and accepting manual input from the user. We control movement by aligning the pencil in the sharpener and also securing the unit to a flat surface such as a table or a wall. We assure dependability by preventing injury during the cutting operation. We assure convenience by containing the shavings for later disposal. We enhance the product by accommodating sizes of different pencils, and we please the senses by minimizing noise during the cutting operation.
Presented here are 2 possible assembly sequences for the pencil sharpener. For both assembly sequences, the pencil sharpener is broken into 4 main sub-assemblies / parts: the base, the sharpener, the crank, and the shavings catcher. The differences between sequence A and sequence B is the order of attaching components to the gear mount in the sharpener subassembly, and the order in which the crank and shavings catcher are added to the main assembly. As can be seen by the table presented, most steps for the assembly in sequence A are fairly straightforward. Some of the more difficult steps include joining the case of the shavings catcher, since they are joined by metal tabs which must be physically bent to hold the case together. Sliding the sharpener mechanism into the base was also deemed difficult because of the unusual shape of the sharpener mechanism and the fact that the helical gears are sharpened, which increases the likelihood of injury if inserted incorrectly. The main difference in sequence B compared to sequence A is that the shavings catcher is installed in the main assembly before the crank is. This results in a much more difficult installation of the crank to the main assembly, since the shavings catcher is in the way of preventing the sharpener from rotating. This added difficulty is reflected in sequence B's total score of 133 compared to sequence A's score of 139.
Here is the function component mapping matrix for the pencil sharpener. As you can see, there are some components which only accomplish one function, and some functions which are only accomplished by one component. This lack of overlap is unfavorable for manufacturing and assembly, as it reveals inefficiencies in the design which need to be eliminated.
This is the bill of materials for the design we evaluated. We assumed that the production volume was around 100,000 units. We also assumed that the tooling life was equal to the production volume for stamping dies and injection molds. The labor rate for assembly was approximated as $15 per hour. The total cost for manufacturing the pencil sharpener was estimated to be $7.06, which is about 70% of the retail value for similar products. We think the manufacturing price is so close to the retail price because the design we evaluated is not necessarily optimized for manufacturing. Other pencil sharpeners on the market may be manufactured in larger production runs, reducing the tooling cost.
Our primary user group is office workers and administrators in a professional setting. Our secondary user group is private citizens who would use the sharpener for personal use. The functions that are common between both user groups are transmitting mechanical energy, accepting manual input, aligning the pencil, preventing injury, containing shavings, accommodating sizes, and minimizing noise. The primary function which differs between the user groups is how the unit is secured to the surface. The primary users would want a permanent fixture for long-term reliability and to prevent theft, whereas the secondary users prioritize the ability to move the sharpener and not cause permanent damage to their walls or furniture. The platforms which would remain the same for both user groups are the gear mount, the bearing shaft, the two helical gears, the two meshing gears, the axles, the crank grip, the sun gear, the size selector lock, the front case, the middle case, the back case, the size selector, and the size selector lock. The module which would vary is the base. For the primary user, the base would be designed to allow for a permanent fixture to a surface, whereas the secondary users, it will be designed to be movable.
As Matt mentioned, the module that we have identified for our sharpener is the base and how it is mounted to a surface. The existing design features two screw holes for permanent fixation. However, the modules that we have expanded include a suction cup design and a clamp. The module interface is the joint between the base and the sharpener sub-assembly. From the fishbone diagram and assembly analysis, we know that the first step in the assembly process is the base subassembly. Because our current design has a unique base for every single variant, this means that differentiation is very early on. This is undesirable. In order to delay differentiation, we can have an identical base that is common to all product variants and only have a common hole in the bottom of the base that the unique mounting feature will be attached to. Thus, differentiation is only in the last step when either a screw, a clamp, or a suction cup is added on to the bottom of the base. Now, the module interface would be at the bottom of the base as indicated in this diagram. We have identified areas for potential redesign of a mounted manual pencil sharpener based on analysis of function, cost, and potential modules. We will tailor our product to the needs of individual consumers by creating a family of base designs that increases the modularity of the sharpener. Thank you.